Hello, in this tutorial, we will recreate 3D example, shipped with BG database, in 2D from scratch. Here is our starting point. We created a project folder structure and imported all sprites. Also, we created a very simple 2D character controller. And here what we want to achieve. Diamonds are spawned on 2 levels and player has to gather them all. As soon as all diamonds are collected, new ones are spawned. The progress can be saved and loaded. Let's get started. Import BG database package. Open database window. Open settings, main. Choose path for database, it should be under resources folder. Then choose path for editor settings file, it can be anywhere. Press create button. New, empty database will be created. Let's review database scheme for our 3D example. Collectible type has 1 row, per each possible object type. Each row defines its own prefab and a sound to play, then object is collected. Player has 1 row for player's data, collected gold, position, and scene. No need for rotation field. Scene table has 1 row for each unity scene. Spawn position defines the coordinates for the player when he enters the level. No need for the spawn rotation field for the 2D version. Bounds define level boundaries and can be replaced with rect. Collectible defines a list of objects currently spawned on this level. Collectible is a nested table for the scene table, created by collectible field. It means each collectible row is connected to the scene table. Collectible defines the type of the object, its position and the amount of gold. And finally, let's replace all vector 3 fields with vector 2 ones. Let's create the tables. Let's create the table rows. After database scheme is created, let's use the code generator. Classes are generated out of database description and they greatly simplify database access. There are 2 main types of code generation, extension classes and mono-behavior inherited classes. Extension classes are used as table rows. Here are the generated extension classes for our example. Each table has its own class, and every field has its own property with proper type. Also, these classes provide very handy static methods for accessing the rows. But these classes cannot be added to GameObject, cause they are not inherited from Unity's mono behavior. That's why there is another type of code generation. And these classes can be added to any GameObject, thus connecting it to the database. Here is how it works. Drag component to GameObject, select a row and that's it. GameObject is connected to the database. Let's start with a script for our portal. We extend it from our generated scene class, cause we want it to be connected to the scene row. All it has to do is to update player's position and load the scene it's connected to. Note, when you see fields, starting with F_, it means the database is accessed. Do not forget to connect it to target scene in the inspector. Now we're going to create a script for our player. We extend it from player class, cause we want it to be connected to the player row. For now, we only want it to update transforms position in the start method. Since we have only 1 row for the player, we'll connect it to database by using init with first toggle. Now, the script for collectible objects. We have 3 different prefabs, so we'll add it to all of them. we'll extend it from collectible row. We want it to add some gold to a player, play a sound, instantiate a particles effect and finally destroy itself. We also want it to show the amount of attached gold. We are going to connect it to database via code. Now let's create a script, which will spawn our collectibles to the scene. It will be inherited from a scene row. First, we need to spawn objects from database to our Unity scene. Second, as soon as all objects are gathered, we need to spawn new ones. Let's use database events for this task. We can listen to any deleted event and as soon as there are no rows in the table, we will create new ones. The last thing we need to add is UI to show the amount of gathered gold. We've added a canvas to a scene and set up a text field. As to the script, we want it to listen to the player gold field and update text field accordingly. At this point, we have a working prototype. As you can see, gathered gold amount is properly shown. But we cannot save our progress just yet, so we'll explain how to do it in the next section. Open add-ons and enable Save Load add-on. Select which data you want to be saved. We want as little data to be saved as possible. The rules are simple. If you create or delete rows during runtime, you want to turn on all three toggles. If you only update fields, you want to mark these fields to be saved. And here's our script for saving and loading the progress. Also, let's modify our player script, so it can save its position before saving. Now we can save and load. You can find download link for final version of this project in the description below. Thank you for watching.